understanding the LCD program, a few fundamentals about LCD. This is our LPC kit. This is our LCD display. It is 2x16 display, 2 rows and 16 characters in each row. LPC is connected to LCD by 8 data lines. These are connected to data lines of LCD. Here for connecting to LCD we are using port 1 pin number 16 to port 1 pin number 23 are connected to data lines of LCD. And then there are 3 enable signals or the control signals. The first one is RS, that is called as register select. Second one is read write signal. The third one is enable signal. Now RS is connected to pin number 30, port 0, pin number 30. Read write is connected to port 0, pin number 29. Enable is connected to port 0, pin number 20. So these 3 control signals are important. There is a command register in LCD. First we write commands to command register to configure LCD. When we write to command register, RS should be 0, indicating that we are writing to command register. Then RW should be 0, indicating that we are performing write function. And then when the enable signal goes from high to low, the data on the data lines get written to command register. Similarly, there is one more register called as data register in LCD. Data register gets selected when RS is made 1. So this is about the fundamental connections between LPC and LCD. This helps us in understanding the program. Now coming back to the program. In the program you can see some commands. These are the commands that are used to initialize LCD. So the first command is this 0x38. This is the command used to initialize LCD as 2x16 display. The second one is 0x0E. It makes display on and the cursor blink. Then the third one is 0x06. Shift cursor right. We are configuring it such that the cursor moves from left to right. Next one is clear the cursor. Clear the cursor. After that, initialize the cursor to initialize the cursor position as line 1 and position 1 so that we can start displaying the data. So these are the 5 commands which have to be sent one after the other for initialization. After initialization, we can start sending the data. Now coming to the program, here we have hash include LPC214x.h. This has to be included. This header file contains the library files related to LPC2148. And then define LCD underscore RS. Here RS is our register select, which is pin number 30. Then RW, LCD RW is read write signal. Enable is enable signal, which is connected to port 0, pin number 28. Now we are defining LCD underscore RS as 0 cross 40000. You can see here port 0 is a 32-bit port. This indicates pin number 0. This indicates pin number 31, 0 to 31, 32 pins. And since our RS pin corresponds to pin number 30, that is why we have made 30th bit as 1. Similarly, for RW, the RW is connected to pin number 29 of port 0. That is why we have made pin number 29 as 1. Same way, enable corresponds to pin number 28 of port 0. That is why we have made 28th bit as 1. So accordingly, we have got the bit pattern 4000, 20000 and 1000, so on. Okay. Then next is we are using these functions LCD command, LCD data, delay, GPIO, initialization. We are not using LCD clear screen. Clear screen we can we can remove it. There is no function being written in our program, so we can delete it as well. Then after that, coming to this declaration part, unsigned character, command 1. So all these commands that we just studied, 380E06, 01 and 80, that we have put in an array, and we are calling this array as command 1, and it has got 5 elements. Then the next one is message 1 and message 2 that we are going to display onto LCD. Message 1 is Pesit South, message 2 is ARM7 LPC 214. Coming back to the main program, here the first function is GPIO init. In this function, we are going to initialize the GPIO ports of LPC 2148. LPC 2148 has two ports, port 0 and port 1. Port 0, there are 32 pins, pin number 0 to pin number 31. Now these pin number 0 to pin number 31, they are grouped as pin select 0 and pin select 1. Pin select 0 corresponds to port 0, pin number 0 to port 0, pin number 15. Pin select 1 corresponds to port 0, pin number 16 to port 0, pin number 31. Pin select 2 corresponds to port 1, pin number 16 to port 1, pin number 31. Now port 1, pin number 0 to port 1, pin number 15 have some special functions. They cannot be used as general purpose input output pins. So we have these 48 pins which can be used as GPIO pins. Now this pin select 1, pin select 0, pin select 1 and pin select 2 are the three registers. With the help of these three registers, we are going to configure these pins either to act as GPIO pins or to act as some other or to perform some other function. Each pin of these ports, port 0, port 1, can perform 4 different functions. GPIO function, first alternate function, second alternate function and third alternate function. If we want to configure port 0, pin number 0 to perform GPIO function, then we have to make this pin as 0, 0. So each pin has 2-bit configuration. To act as GPIO pin, 0, 1 represents first alternate function, which is PWM function. 1, 0 indicates second alternate function, wherein the same pin is used to perform analog to digital conversion. Then 1, 1 is the third alternate function. So each pin can perform 4 different functions. For 4 different functions, we require 2-bit code. Okay. Now, since we are using all these pins, whatever pins we are using as GPIO pins, we have to first configure these pins as 0, 0. Remember, each register is allotted with 16 pins, 2-bit code for each pin. So, each register here is a 32-bit register. Clear? So, pin select 0, pin select 1 we are using, and pin select 2 we are using, because if you remember the diagram that we just learned, in the diagram port 1 16 to port 123 we are using for data lines. So port 1 pin number 16 to 23 come under pin select 2. Port 0 pin number 16 to pin number 31 come under pin select 1. So in this program we are just going to configure pin select 1 and pin select 2. Here you can see all these pins are configured as 0, 0 because we want to use all these pins as GPIO pins. The next one is IO direction. We are setting, once we configure them as GPIO pins, the next thing is we have to select whether they will perform input operation or output operation. Now in this diagram, as you can see, 28, 29, 30 are used to send the control signals to LCD. So these 3 are output pins. And with the help of pin number 16 to 23, we are sending either command or data to LCD. So again, these 8 pins are also output pins. So we are setting the direction of these 3 plus 8 pins using IO direct 0 and IO direct 1. Now IO direct 0 is for configuring pins of port 0. Which 3 pins? 28, 29 and 30. These 3 have to be configured as 1 because they are output pins. Okay. So accordingly, pin number 31 will be 0, 30 will be 1, 29 will be 1, 28 will be 1. So that gives rise to 7 here. And the remaining bits are all zeros. The next one is IO direction 1. Here we are going to configure port 1 pin number 16 to port 1 pin number 23, which are connected to data lines of LCD. So we have made this pin number 16 to pin number 23, these 8 bits as 1, 1, all ones, which gives rise to FF here, indicating that these 8 pins are output pins. So we are setting the direction of GPIO pins with these 2 commands. Next, coming to clear 0, IO clear 0 will clear all the pins of port 0. IO clear 1 will clear the selected pins. Here pin number 16 to 23 are made initially 0. Here also 30, 29 and 28, these 3 pins are made 0. This is just for initialization. So these are our initialization. These are the initialization commands for our GPIO. First we will set the mode, that is GPIO mode. Then we'll set the direction, either input or output. Then we will clear all those pins. Okay. Coming back to main program. In the main program, the first thing is we have to start sending the command to LCD so that LCD gets configured. As we have seen, there are 5 commands. So here the for loop is set up for 5 times, and each time we are going to send one of these commands, one after the other. So every time a command is sent, we are calling this function LCD command. Let us go to LCD command function and see what happens in that function. So in this LCD command function, we are sending the parameter in terms of the commands. That is, first we'll send 0 cross 38, then we'll send 0 cross 0 E, so on. So that is our parameter here. Value indicates the command. Okay. Next, here you can see IO1 pin value left shifted 16 times. This we have to shift 16 times because whatever command we are sending, that command has to get aligned itself to pin number 16 to 23 of port 1. Okay. So that is why we are shifting it by 16 times. When you shift it by 16 times, the data, that is 38, the first command 38 is available exactly at these pins, pin number 16 to 23. Next, what we do, since we are writing to command register, RS has to be made 0. So here we are making IO0 clear LCD RS. Remember, LCD RS has been assigned this value 40000000, which indicates pin number 30. So initially we will make that pin number 30 because we are writing to command register. Then again we will make read write signal 0 because we have to write the command. Okay. Then the next thing is the enable pin has to go from high to low. So initially we are setting this enable pin. After some delay we are resetting the enable pin. So these three lines give a high to low signal on the enable pin. Once high to low signal is given on enable pin, the data or the command which is there from pin number 16 to 23 will get stored onto command register. Okay. So this is how we are going to write the commands one after the other in LCD. First make RS 0, then make RW 0, make enable high, then make enable low. So these are the control signals. So go back to the main program. The next command is sent like that, one after the other. The 5 commands are sent. Once the LCD is configured, the next thing is we have to start displaying the data. Here you can see the first message is Pesit South. We have to display this Pesit South. So that is done using this for loop and the function call. So the for loop will get executed till it encounters a null character. So every time LCD data message once. First time P goes, then E goes, then S goes. So it continues. LCD message 1 is a function. This function is exactly similar to LCD command function. LCD command function. Here we have LCD data function. Only thing that we have to change in this data function is that we have to make RS register as 1 because now we are writing into data register. So first send the data onto lines pin number 16 to 23 of port 1. That is why we are shifting it 16 times. Then set RS register because we are going to write the data to data register. Then send a 0 signal onto read write because we are going to write the data. Then once again make enable signal, enable pin high, after a delay make it low. So once this happens, data on the data line gets written onto data register. Okay, so the first character is written, then the second, so this goes on. That is the LCD program. Here we have a delay function. Okay. Next, coming to this main function, here we have one more LCD command 0C0. This 0C0 indicates that we have to start displaying the next message on the second line. In this for loop, we have displayed the first message, that is Pesits out, on the first line. Then we will give a command to LCD telling it to print the next message in the second line. So in this for loop, we are displaying the second message, that is ARM7 LPC2148 in the second line. Okay, so then while one indicates an infinite loop. So that is LCD program.